So here, for the first one, the work function is equals to HF naught. F naught is what? 5 over H, right? So the phi value is like 7.8 into 10 to the power minus 19 over the Planck's constant 6.63 into 10 to the power minus 34. What is your answer? F naught gold. It said like 1.18 something, no? Shamika?
Yeah, 1.18 into 10 to the power 15.
15 hertz, right? In the same way, you have to follow the same way with the individual values, right? In the same way. When radiation of frequency 18 to the power 14 applied to calcium, calculate and find the energy of a photon. Energy of a photon E equals to HF H is 6.63 into 10 to the power minus 34 multiplied by 18 to 10 to the power 14. Sorry. What is the result you got for this one?
I got 5.3 into 10 to the power minus 19.
Okay. Kinetic energy of the photon leaving the calcium. So to find out the kinetic energy, what you have to do?
Energy minus the work function.
Energy minus the work function. So for calcium, it has a lower value than this. 5 point for the answer number 2. Here, this is the answer number 1. Yeah. (1.0 into 10 to the power minus 19 joule). Is that your answer?
Yeah.
Okay,
yeah.
Now the kinetic energy of this one we just found. Now we need to find out the speed of the photoelectrons leaving calcium. It's a really simple way. Firstly, we have to write what the equation. E max equals to K max, equals to half ME V max square. So now I know the E max value is like minus 19 joule, but half M is like 9.1 into 10 to the power minus 31 kilogram times V square is here. So cross multiply, and V max equals to 2 times 10 to the power minus 19 divided by 9.1 into 10 to the power minus 31 and the square root of this one. What is your answer you got for this one?
468,807 meters per second.
So why don't you convert it to powers? Tell me that answer again.
So in powers or in the actual?
No, normal value.
468,807 meters per second.
Right. So this is really ugly. So we have to write it like 4.6 into 68 into 10 to the power 5 ms minus 1. Right?
Yeah.
Okay. Now let's straight away go for learning the next part. What is the next part? It's called the photoelectric cell experiment.
Quickly
go for that one. So now just start to read the page number 136 and 137 very quickly. Get used to the terms, then I'll come to the board and explain this thing again quickly and sooner. Okay. Okay, have a good look at. So when sunlight or any other UV light or any radiation falling on this cathode, right? It is the one normally in sieve shape. So the shape is also to
Cathode is C-shaped.
yeah, normally actually not C-shape, it's like a concave, right? Concave cathode, and this one to grab all, because normally all the electrons were directed towards this one. The best way is to use a cathode in a concave one. So somehow the electrons may leave this surface. Now when the voltage of this one is 0, still you may still see what? Some current is flowing across the ammeter. Right? Why? Because these electrons may leave the surface with different amount of energies, because the light ray may contains different amount of what? Mix of radiation. So some of the electrons may get really high energy, others might get really low energy. Low energy ones will try to stay together on the surface. So those ones moving away might reach here, and some other electrons are still moving to some other directions rather than falling on this anode, right?
Yeah, got it.
Yeah, imagine only 10% is just coming. Now there is a very slight current in this microammeter. Actually, it's a microammeter, very small current can be read from there. So there is a current from here. So, and the voltage is reading is 0. Now you just keep increasing the voltage value. And as you increase the voltage, you may see the current in this one keep increasing and increasing and increasing, right? There is a certain graph that is missing in the textbook. So the graph is something like this. Voltage versus current. There is an initial current at the beginning. When you increase the voltage, it will go up and finally become constant. Why did it become constant? Because all the leaving electrons being added towards there, once this becomes positively charged, all the electrons, even the electron just rested on here, getting attracted to this terminal and stay there. So now no more electrons are producing, so the current is constant. When you reverse the voltage, what would happen? Now even the strongest one are reluctant to go towards here and drag back to here, because now the positive and negative terminals are being changed. Can you understand?
So can you explain that part again?
Now the positive and negative terminals being inverted from the supply.
Yeah.
Now what happened? This end becomes negative and this end becomes positive. All the electrons being repelled and got into attracted towards the cathode itself. So the strongest electron, that means the most electron with the highest kinetic energy, also attracted back to the cathode. So the voltage and the current across this one stops. The current stops means this voltage is known as Vs, stop potential.
Okay.
You may need to know this graph even. So that's known as stop potential. So you know another equation, W equals to QV, your O-level equation. So from this one, what can you, what is the work done? What is this work done? Against the maximum kinetic energy. So it could stop the electron with maximum kinetic energy. Can you understand? Could electron with Kmax. So this work done is nothing other than Kmax. Kmax equals to, charge is what? Charge of an electron.
One,
voltage
right?
is
-1.
Yeah. Vs, stop potential. We call it what? Stop potential. Understand?
The charge is the electron,
Yeah.
the electron charge
Yeah, charge of an
or the
electron. So that's why I represent it
yeah,
using the symbol
okay.
of just E.
Yeah.
That's what is there. So this is
So
talking.
can you I got confused. Which one is the cathode and which one is the anode here?
Wait.
Like at the beginning of the experiment?
Yeah, this one is the what? Anode. Sorry, cathode. One it leaves the electron is the cathode. The one
Okay.
getting electron, the positive terminals are just connected this. What? So anode, right?
Yeah, so the C-shaped one is the anode.
Yeah. No, C-shaped
Okay.
one is the cathode.
So why will the electrons go towards the cathode?
No,
Because
this
it's
diagram is completely inverted. That's what I'm telling you.
ah
It should be in the other way
okay.
around.